Okay, so 31 notes and pair check. The title for today is Graphing Linear Equations. Write that down. In case you need to get online, go to YouTube. Don't forget our YouTube channel is in the corner of the smartboard, the dry erase board. The Coach Moore's Algebra 1. Just type that in the search bar and take you right to it. Okay? Our objective today is students will determine whether a relation is a function, and then we're going to find functional values. Pass skill 1.2a and 2.2c, I. This is kind of really starting to get into the nuts and bolts of it, really, I guess. Okay? About 80% of your test is kind of stem from this. And then I'm talking about your UOI test. Okay? Okay? And you can do pretty good on this, and you got a fighting chance. There's going to be some other stuff added. So. Everybody good on this screen? Okay? All right. Here's our key concept. Write this down. This is what we're talking about today. We're talking about standard form of a linear equation. Standard form of a linear equation. Make sure that you write this part down too. It's a brief explanation. I'll kind of pull it apart and decipher it for you here in just a sec. Standard form of a linear equation is ax plus by equals c, where a is greater than or equal to 0. A and B are not both 0, because what happens if they're both 0? What's anything times 0? It just disappears, doesn't it? Okay, so the last thing, and this is probably the most confusing part, A, B, and C are integers with a greatest common factor of 1. And I'll explain that in just a sec. You can write the examples if you'd like, I don't care. Just use a pen. When you take a note, you can use a pen. You got one? Okay, you guys got it? Okay. Of course, we just said A and B cannot be what? So this part right here and this cannot be 0, because if they are, if they're both 0, whatever we multiply times is just going to leave us what? C. Okay? It would actually be 0 equals whatever your C is. That's not a true statement, is it? Based on what we talked about in chapter 2. Okay? All right, last part. Let's see if anybody can tell me what this means. A, B, and C are integers with the greatest common factor of 1. What does that mean? Anybody tell me? Raise your hand if you know. Yes, Austin.
No.
No, not necessarily. Yes, Michael. No. Anything can be multiplied by 1. Common factor. Greatest common factor. Maybe. Okay, write this down. What this means is just a fancy way of saying no fractions. Write that down. It's just a fancy way of saying no fractions. Okay? And of course, you know, like in this one right here, what's A? 3, right? That's my A. What's B? 2, good. What's C going to be? 5, good. So you know where those come from, right? If it doesn't have a number in front of it, it's always understood to be what? 1, good. What else do you notice about X and Y? X and Y are, they're not by themselves. What else? In relationship to the equal sign. Very good, Michael. They're on the same side, so write that down. Draw you a little arrow. X and Y are on same side. Yes.
On the second example, it's x equals -7. The b equals 0. What is the 0 in it? Or is it just there to show it?
Yeah.
Okay.
You really don't have a B, do you? Where's your Y here?
So there's no one.
Exactly. So what kind of line is that? What kind of line is that, people? We just went over it yesterday. Very good, Dennis. That's called a vertical line. What do we say about vertical lines and horizontal lines? Are they considered standard form?
No.
Why not?
Yes.
Yes, they are. Okay? That's considered standard form. That it only meets half of the requirement, but it does meet half of it, right? Hello? Right there?
No.
It does meet half of it, but it doesn't meet both of them. Okay? But it's still considered standard form. A vertical line is not a function, but it's still considered standard form. Okay, good question. All right, so X and Y are on the same side. What else? X and Y, write this one down. This is a big one. X and Y are raised to the what? Power. First power. So it has to be X to the first and Y to the first. Okay?
Why does that matter though?
Huh?
Why does that matter?
If it's X squared, it's going to give you a U shape. Is that linear? What's linear mean? Like say, what kind of line though? Straight line, right? If you start putting exponents on there, it's going to put curve on your line. Okay? When we get to chapter 8, we'll get into that a little bit more. Those are called quadratics. And when you get to algebra 2, you'll be dealing with those quite a bit. Okay. You guys know what a quadratic is?
No.
Okay. All right. Example 1, write this down. EX1, you're going to identify a linear equation based on the information that I just showed you. So you got 5x plus 3y equals z plus 2. Linear or not linear? Why, Michael? There is a c. What's my c here? It's 2. What's my a? Good. What's my B? Why is it not linear? Extra what? Variable, good. Because of that, circle that. Makes it not linear. Extra Z. Does it meet all the other criteria? Is X to the first power? Is Y to the first power? Or a good check. A and B are not zero either. Just determine that, right?
So if there's zero, it's not an equation?
Huh?
If there's zero, it's not an equation.
If that's zero and that's zero, both at the same time, you can't have that. Okay? Also, I forgot, write this down, on the previous slide. Sometimes you're gonna see standard form written like this. Write that down. Standard form is gonna be written like that. They'll do it sometimes on the EOI test, and they'll do it a lot of times in Algebra 2. That's also considered standard form. Okay? Any questions on this? Write this one down. This is example 1B. Example 1B. Determine whether 3/4 X equals Y plus A. Is it a linear equation?
No.
You sure?
Yes.
Is A 0? Hello?
No.
Is B 0?
Nope.
No? What is B? 1, good. You got a C. Is X raised to the first power?
Yep.
Is Y raised to the first power?
Yep.
Is it linear?
No.
Yes.
I thought those were fractions.
Okay?
If it's a fraction.
It can be a fraction. Here's the next part of the question. Does everybody know? What fixing to ask? Is it in standard form?
No.
So again, is it linear?
Yeah.
Yes. Is it in standard form?
No.
Okay. So once we determine it's linear, then we can write it in what? Standard form. What do I gotta move? Yes, Michael?
So B doesn't have to be with the A, like on that side of the equation. Like you know it's AX plus BY equals C. It doesn't matter like where the B is, as long as the variables are there.
Right. But it matters to get it in standard form though. And that's what we're fixing to do. What do I need to do to get it in standard form? X and Y gotta be on the same side. How can I move something to be simple right here?
Subtract it.
Subtract what though?
Negative 1.
Rewrite it as 3/4 X minus 1Y.
Equals. Yay.
Is it in standard form? It's close, but it's not all the way there. What am I gonna do next? Okay, now, listen to me very carefully. Everybody's had a hard time with this. I'm undoing the fraction, not moving it. Okay? You hear what I said? I'm undoing the fraction. I'm not moving it. What's the difference? If I'm undoing the fraction, I multiply by its, no, I'm not moving it. Multiply by its denominator. You guys here, make yourself a note right now. I'm not moving. I'm undoing the fraction. If I wanted to move the fraction, then I would multiply by its what, Zeta? Okay? Here I'm just undoing it. If I multiply one side by 4, I gotta do the other side also. Now watch what happens. Everybody watching? You guys are following this because this is what people miss the most. What property is that? Okay, so what am I left with if I multiply 4 over 1 times 3/4 x?
3x
Very good.
minus 1,
What's 4 times a negative 1y? 8 times 4 is 32.
So why do we, like,
What did I say? What property is that?
Like everything.
I thought we didn't do that. Like, in like chapter 2.
Again, what am I doing? Am I moving it or am I undoing it? Okay? Trust me. Okay. Don't overanalyze. Yes.
What do you guys get when you multiply 4 over 1 times 2 over 4?
12 over 4. Which simplifies to,
Oh, because I just multiplied 4 times 0.75 and then I have to, I don't know, if I change the
don't do that. Yeah, don't do that. Any questions? Okay. And you guys understand that this is the same as that. Guys understand that, right? And vice versa. I consider that into that and that into that, all right? What else can I put it into? What's the sister? Good. Which is? Good, very nice. Well, okay, write this down. Example 2. Find the x and the y intercepts. This is really, really easy, but it's missed a lot. Tommy, are you with us? You don't look like you're with us. Write this down. Right. That'll help keep you awake. Find the x and y intercepts of the segmented graph. Okay, follow this format. I want to find the x-intercept, right? X, INT. What's INT stand for? And then draw you some parentheses right underneath it. Just like that. Do it now. Write it down. Follow this format. Got to keep this organized so you're going to get lost. Right next to it, what else do I want to find? So Y, INT. Draw your parentheses right underneath it. I don't want you guys being lost. It's just this easy stuff. What is one thing about the x-intercept that's always going to be true no matter what? Right? What about the ordered pair though? What do I know about the ordered pair that's always going to be true?
The y is going to be 0.
What?
The y is going to be 0.
Exactly. The y is always going to be 0. Write that down. Y coordinate is always 0. Is that true in every case?
No.
Yes. It cannot not be true. Okay? It cannot not be true. If it crosses through the x-axis, then it's the x what? Intercept. And it has to have a 0 coordinate of y. Be with me?
Yeah.
Okay. If it's the y-intercept, what do you know about the ordered pair? X is always 0. Write that down. X is always 0. No matter what. No matter what. It's always 0. Write that down. Because this will help lead into the next question. Okay, so now on this graph, the segmented graph, everybody know what segmented means?
Yeah.
What does it mean? There's no what? Okay. Yeah. So what's the x-intercept on this one? 4 and what? 0. What's the x or the y-intercept?
0 to 100.
Again, x is 0, y is 0, right there. Everybody with me? Okay. Write this one down. We're going to graph a line using the x and y intercepts. How many points do I need to graph a line? 2. Okay, this is also, write this one down too. This is the first method to graphing lines. This is the first method to graphing lines. There's going to be 3 of them. I'm going to show you 2 today. First method to graphing lines. Okay. Notice, what form is it in? Okay, we're in good shape. Just leave it in standard form. I want to know the x-intercept. Again, write your parentheses. What do I know about the x-intercept? Write that in there and leave your x-coordinate blank. After that, write the equation right underneath it. The equation that they give you. Now, remember the other day? What did I tell you about x and y? They come from the order pairs. So, if that's true, what can I put here? Can I solve it now for x? I can just take that off, can I? Divide by 4, x is 1. Okay, so plot that point. 1 and 0. I know it has to be on the what? Because it's the x-intercept. Okay, so 1 and 0 right there. Okay, y-intercept. Again. Leave my y-coordinate blank. Again, write the equation that they provide for you right underneath it. I'm going to put that 0 in for that x. What's 4 times 0? What can I put in front of the variable if it's not there?
1.
Is y by itself? What do I have to do? Y equals? Any questions? Anybody need more time with that? Yay, nay? Now move on? Okay. Example 4, graph I'm making a tab table. This is the second method to graphing lines. This one's pretty easy too. Okay, now notice what form is my equation? What is that? Which is? Slope-intercept form. Now, the whole reason that I have to do this, you guys pay attention to this, you guys are starting to wander off. The whole reason you have to do this is because y, is it by itself? Yeah, so that makes it what kind of variable? Dependent. By rule, by default, that makes x what? Independent. when a variable is independent, then I can put any value I want for it. You guys hear what I just said? I can put any value I want for it when it's independent. This is also considered what? Write this down. Function form. Gotta know the vocabulary, gotta talk the talk. It's also considered function form. Instead of y, I would just put f of x. Right? That's what we learned yesterday, hopefully. Okay, got a pretty little table here. Now, I just told you, you only need how many points to graph a line? 2. On this one, you need to go ahead and do 3. Okay? Now, I have 5 numbers up here. Do I need to use all 5 of those numbers? Which ones would you guys use?
0, 1,
I would you probably use 0, 1, 2, or even simpler, in my opinion, -1, 0, and 1.
2.
Either way, you want to go. So it's going to still give you the same thing. Okay? So now, since I have a function form, I can go y equals 2 times -1 plus 2, which gives me what? What's my output value? Or my y, what's it going to be? 0, isn't it? There's my ordered pair. Now, what do you know about that? It's also called what? Isn't it also the x-intercept? How do I know that? Because y is 0. Plot a point. Okay, next one, y equals 2 times 0 plus 2. What is that going to, what's my output? What is that? The y, what? Intercept. Plot a point. Okay, and then the last one, y equals, what is that?
4.
Tommy, you're going to struggle really bad if you just keep falling asleep and don't write any of this down. But you're just like falling asleep. Half of it's not going to cut it. You're going to get half of it wrong. Everybody good? Yes, no, maybe. You guys wake up. Hello. Answer questions so I know we can move on. Okay? Communicate, participate so I know we can move forward. Like talking to the wall sometimes. Here's the third method. I'm going to give you a little bit of information on the third method. Anybody know what the slope is here? Yeah, but what else? Isn't it right here?
1.
Isn't it 2 over
1.
1? So from here I can go up 2 and right 1, up 2, right 1, up 2, right 1.
Rise over right.
Okay, can I go down?
Yeah.
Okay, what would my slope be here? -2 over -1. What's a -2 divided by -1? It's the same thing as 2 over 1, isn't it? Okay, so down 2, left 1, down 2, left 1, down 2. Amazing. What is this little number right here? Isn't it my y-intercept?
Yeah.
Which is at +2. So I just told you basically what the third method is, didn't I?
Yes. Yep.
In the equation, if I put it in function form, I can find my y-intercept and then count my what? Count my slope.
Okay.
Brace yourself. Linear or not linear?
Linear. Wait, which one?
Why?
Because,
Two Y's. Simply put, there's two Y's. So that would be no. What else could I put instead of no? Not.
Linear equation.
Okay. Non-linear, good. Okay, some other things. You're gonna see it some different ways on the test, all right? What about the second one? Kind of hard to see on your paper. What about this one?
Yes.
Very good. Why? Because there's one X, one Y, and they're both raised to the first power. What form is it in?
Regular.
standard.
I remember saying regular, it's
Sorry.
standard form. X and Y are on the same side, so it's in standard form, right? Okay. Look at this one. Graph each equation by using the X and Y intercepts. So the first thing I need to do is what? Keep my information organized. Start there. Which coordinate is 0? Okay, and then next to it, I mean, you can kind of see a pattern happening here. Which coordinate is 0? Guys with me? Do I have to change anything about the equation? I can leave it in standard form and do this, right? 2x plus 0 right? Okay, 2x plus y, 2 times 0. Oops.
You want us to keep, making them like all the way to the end of the graph?
Yes. That's a great question. Why do we need to, why, and I don't do it just for speed purposes. But Jetta brought up a good point, and I'll explain why. Your lines need to go all the way up to the edge. Why do they need to go to the edge? When we start doing inequalities, okay, you're going to have to shade one side of that line. Okay? Plus, when we start doing systems, you're going to have two lines. And you're only going to have to shade one part of it. So that's why you need to go all the way out to the end. Okay? Really good question. Okay.
So do we use that equation for creating class?
Now, that's what I'm fixing to talk about. Graph the x minus y equals -1 equation by making a table. Okay, now, if I'm going to use the table, my equation has to be in what form? What form does it have to be in?
Standard.
Slope intercept, which is the same thing as No. Starts with F. Function form. Putting it in function form gives me a dependent variable and an independent variable. If it's independent, then I can put in whatever numbers I want for X. Doesn't matter. How do I get this in function form?
Minus,
Subtract X from both sides. It gives me negative Y equals. Now notice, where am I putting the X? In front or after? Put it in front. You gotta start doing that. Start putting it in front, right here. Now what?
put the one in the
What's that give me?
y equals x minus plus 1.
Okay, so now I got 1X plus 1. What numbers do you guys want to use?
And negative.
Why did you have to go? You don't have to use that many. 0, 1, 2. Just gotta use 3. Okay?
Okay.
Everybody?
One.
What is that? I'm gonna pencil that in. Kind of happy. Keep going faster. 3. Then take these 3 points, and in box 4, go ahead and plot them. What was my first one? Positive 1 or negative 1? One and 2, was that the next one?
Yep.
2 and
Okay, Karen, first problem.
that's it. Are they CYP there, or you gonna wait?
Wait.
Wait.
Okay, Monday, we'll do it Monday. Take the remaining time, 10 minutes, to finish up your prayer check. I guess if you already passed it, no. Where are you at last year? That's a different test. That's a TEAS test. TEAS, Texas Assessment Knowledge Skills. That's a different test. Are they using that now for STAR? Because when I taught down there, it was the TEAS test, or TASS, TASS. Spent my first 5 years down there. About 5 years. Austin area. Everybody's here, right? Except for
Skylar. Now three. Negative 2.